this. All right, so at the top of the list, and I did start with, if you think about, if you've seen TouchMath Pro and you've seen the skills rainbow and how it progresses vertically, I've started still in the upper grades, but I've started with just recognition of 2D shapes. So if the objective is to review the properties of 2D shapes, to understand that shapes consist of angles, angles consist of rays, rays consist of lines, lines consist of points, right? And then that's what I was looking at there. And then also reviewing open and closed shapes. So those are our objectives. And if you were to look in it would be Unit 9, Module 1, Activity Sheet 7. So if you're taking notes, you can write that down. Again, that would be Unit 9, Module 1, Activity Sheet 7. And in there, they talk about using pipe cleaners. Now, I know you teach high school, you teach middle school, some of you teach elementary school, but I, as a high school student today, as I was preparing, I loved playing with the pipe cleaners. You know, you're never too old. It's just, they don't necessarily do it on their own because their friends may make fun of them. But in class, if they're all doing it, then they're all on the same playing field. So don't run from the pipe cleaners. So what we would use these for is to use the pipe cleaners to build shapes. Not only building the shapes with just one pipe cleaner, but tying them together to make the joints. When you put the knots, then they each form a corner. And so that becomes an angle as we start to talk about the angles. So now I have a purple and I've got a gold, and then I'm going to put a green one down along the bottom. So now they can clearly identify where the angles, where the lines intersect to form angles. And now this, again, becomes very tangible, very practical for them in that regard. So just a nice way, quick way to make this, this triangle. Of course, if we were having them, we would, with just one color, we would do a circle, right? Because there are no lines, there are no angles with the circle. We can continue to do this. I know my packet has several colors, so we could now take that triangle, what was a triangle, and turn it into a square, open it up and turn it into a square, so that now we have one more line, one more angle, and we're facilitating this discussion with the students to now define the properties, identify the properties. That's not a great square, but if we had it on our desk, if I had some workspace that was other than Starbucks, then it would be a square. Kind of a square, yes. And so now they can talk about those, the characteristics of the square, compare the characteristics of the square to the triangle. They could make some other shapes, and to the circle, so on and so forth. So again, that's number one of my top 10. The second one comes from Unit 9, Module 2, Activity 27. And honestly, it was an improv on my part because I didn't have any cubes. I didn't have any 3D shapes, but we want our students to be able to compare and contrast the 3D shapes. So let's build them. And so what I went and got was some modeling clay. And so with the modeling clay, it's easy enough to pull it apart, and students would just love to do this. It's not like Play-Doh, so it's not really messy. It's not all sticky. Nothing against Play-Doh, but that's, modeling clay is drier, if I could say it that way. But now I have this, I have now a sphere, and I could then have my students press it out to turn the sphere into a circle. And now we're going to have a conversation about the difference between a circle and a sphere. And then again, we could make the circle. I made a cube. Right, so I've got this cube, and we're going to have the students talk about the characteristics of the cube, the points, the lines, have them take the cube now, and let's turn the cube into a square. So we're going to flatten it out and turn it into a square, and be able to, or maybe make another one. We'll have them make a square with the modeling clay and a cube, sit them side by side, and have them compare and contrast, maybe a think, pair, share, so that they can identify the similarities and differences between a square and a cube. I've got a pyramid that I made. And honestly, I was really impressed with that I could make a pyramid out of modeling clay, because again, this wasn't something that I did in school. But once I picked up on what where my deficits were, I got a 99% A in that class, mind you, my senior year. And when it was time to graduate, and I finally took that class, and I got it. So now we have our pyramid. We again have the students talk about the characteristics of the pyramid, the triangle, we can do the rectangle, the square, and have them play with this. So I think that's a great way. So that is number 2, using modeling clay. The next one is a mirror. And just so you know, again, I'm referring to where these are, where I found them first in the curriculum, because I wanted to make sure that you understood that what's in our curriculum is not just using TouchMath TouchPoints. When you open up the TouchMath TouchPoints, the shapes, as well as the 3D numerals, on the top of the box, when you turn it over, there's a styrofoam insert, and inside that styrofoam is a thumb drive. With that thumb drive, there are all kinds of activities on there to use the manipulatives. So make sure you look at those. You can print out the activity sheets. There are teacher's guides in there and suggested ways of using it. But today I really wanted to focus on the other stuff that's in the curriculum that doesn't require the TouchMath TouchPoints or making an additional purchase. So you're welcome. This is not a sales pitch. So at any rate, I really enjoyed the concept of using a mirror, so that when we're trying to help our students recognize, define, identify, and draw lines of symmetry, we can use the mirror to do that. Because what we would do is printing out one of the activity sheets that's on the thumb drive or inside your curriculum kit, you would just have the students you'd provide them small mirrors, and then they would place the mirror on the line of symmetry to see the reflection. So that helps them see the lines of symmetry, and how when they, we could have them fold it and they would see that both sides are the same. And then once they fold it, instead of having it folded, now they can unfold it, put it on the line of symmetry, and they would see that direct reflection. So I thought that was a really cool idea, provided that the mirrors are safe. This is a rather large mirror. It was the one I could find at the dollar store. But you may have access to something already, some other mirrors. They have the flexible mirrors that wouldn't break. You could find those somewhere. But I just love that idea of using the mirror to show lines of symmetry. That was number 3. Number 4, and again, these aren't in particular in order of my preference. This is in the order that I found them in the upper grades curriculum. This next one does go with the shapes, the TouchMath shapes. So I told you this was going to get messy and loud. This is my measuring cup. It must want to go next, but we're going to hold off on the measuring cup. And we're going to go to our shapes, and be glad there was nothing in my measuring cup yet. I did have the presence of mind to say I'm not going to put water in it yet. And so I've got all kinds of shapes here from our shapes manipulatives kit. And what we can do is begin with just asking the students to compare one rectangle to another. What do they have in common? How are they different? Yes, we know that the color is different, the size is different. What makes the sizes different? How different are they? Is it exactly, is it twice as big? Not quite, so we're going to have them compare. They have 4 sides, 4 angles, right? Some of the lines on this one are longer than the lines on this one. So depending on the skill of your students, the greater in depth they'll be able to go with their comparing and contrasting. But the point is, they've got manipulatives in their hands, and now they can bump these up against each other to see physically and feel physically what the differences are. Then we may have them pick up a square. Now what's the difference? They both have 4 sides, they both have 4 angles. However, now we've got 4 equal sides. Here we have 2 sets of 2 equal sides. So again, facilitating that conversation becomes much easier when they can pick these up and lay them on top of each other. And then let's take a look here. These are the same color. They have 4 sides. sides, but what's the difference between these sides and these sides, with these angles and these angles? So that's how these manipulatives can be used. And like I said, inside the box with the shapes kit, there is a thumb drive at the top, in the top of it, so that you can access all these activities and ideas for using these. But I did want to pull these out because in Unit 9, Module 3, activity sheet 62, one jumped out at me that really helps the students to identify the number and type of the sides, the length, the lines in relationship to the lines on the sheet, right? So now they can take these manipulatives, place them directly on the activity sheet. And for instance, let's see, I know there are some that have 3 rectangles. And so the students would put the rectangles side by side onto the sheet, and now they have this, they can fill them in, and they can see at this point, right, I've only got 2, but there are 3. So now we can even start looking at fractions, right? We were able to fill 2/3 of the boxes that were on the activity sheet using these manipulatives. So now we're beyond just identifying or comparing and contrasting 2D shapes, and now we can start using these for fractions. Let's see here. One other idea, speaking of fractions now, I've got a small square and a large square, and I could have the students start stacking these and see, okay, how many squares would it take, how many little squares does it take to fill up the big square, right? So now again, we start looking at fractions and having that conversation. Same shape, different sizes, one shape can, or 4 shapes can fill just this one shape. So lots of directions we can go. And then we have the 6-sided figure here. We want to start having those conversations. And I think, and then we have circles as well, big circles, little circles, different colors, different sizes, all within that, the kit, the box of the shapes. All right, moving right along. So far we've covered the pipe cleaners, the modeling clay, the mirror shapes, then the measuring cup. And this one I know is something that we can all relate to. Fortunately, this one is plastic. I did have a glass one. The operative word being did. Yes, it fell and broke everywhere. But this helps students if our objective was to learn relative sizes of measurements that are customary in the US, but we could also use the metric system right here and make those comparisons. So if I take the water that's in my Starbucks cup that fortunately had a lid on it, and we pour the water in there, now I can see as a student, my half a cup, what does a half a cup equal on the other side if we're ready to start having those conversations. So, and then also helping them convert from ounces to cups to pints to quarts, so on and so forth, milliliters to liters, so on and so forth. The bigger cups we have, the bigger measuring tools that we have, we can start filling them up and moving them from one to the other to have those conversations as well. So don't forget about things that you may just have laying around the house that we take for granted. We don't have to buy everything. There are things that we just have access to. And this comes in Unit 9, Module 6. I know there's activity sheet 144, 150. Those are the ones where we start looking at units of measurement and having those conversations with students. Number 6, I really like number 6. Number 6 makes use of graph paper. And graph paper, when I think of graph paper, honestly, I get like the shivers because it was something that I didn't necessarily enjoy because it was just a matter of, drawing. It was just a way for us to write, to keep things in boxes. But again, that was very abstract. If you're just writing numbers so that they line up properly, that's abstract. I needed the concrete or even the representational. So what we might do with the graph paper and some scissors, if the objective is to use tables, equivalent fractions, tape diagrams to identify the differences in quantities and comparisons of ratios. So that might be the objective. So what we would tell our students is to, on activity sheets 39 through 52 in Unit 10. So we're in Unit 10, Module 2, from 39 to 52. It's all of these activities and asking students to compare whole to part. on diagram activity sheets. So in one case, I may have them take a colored pencil, take your red colored pencil. Never realized how important colored pencils are. It just makes things pop out. It makes it attractive, visually stimulating for the students. So take your red colored pencil, and what I'd like you to do is count 10 squares, but only shade in 5 of them. Shade in 5 of the 10 squares. And now what we're going to do is cut it out, and now you have a tape diagram. So having students create their own manipulatives. So now they have tape diagrams, and they could do several of these, right? So now just color in 3 using your green colored pencil. So we could just go on and on and on, and they create these tape diagrams. And then beyond creating the tape diagrams, then we're going to ask them to write the ratio. How many squares are colored in red compared to how many squares have been left blank? So in this case, we've got 5 to 5, right? 5 out of 5 are red. But if we then use green to color in 3 of the 10, right? Now we can have that conversation, and we're having the 3/10 conversation. So this can go so many directions and just beyond the introduction of this, but now getting into, we've got ratios, we've got fractions. So it's just, I just absolutely love this. Again, very low cost solution that can be used over and over again. I mean, you look at this piece of graph paper. It's graph on one side and lined on the other. So you look at this graph paper. I mean, you could get a ton of those. You could get a ton of those tape diagrams out of there for students, and it gets their hands busy. It's hands-on. So next, I'm going to pause. I think we're just about halfway through my 10, and I'm going to look and see. No questions. Okay. So next, what we're going to take a look at is beads and string. So this is going to take us, if you find that the tape diagram is a bit challenging for your students, or they just don't quite see the unit value yet, we could use string and beads, right? My daughter used to wear these in her hair as a little girl. She's not a little girl anymore. So now in this case, I've got 4 beads on this black string, and I could ask the students, okay, how many blue beads compared to the yellow beads? So here, 3 of the 4 beads are blue. What about yellow? 1 of the 4 beads are yellow. Or we have 3 to 1 in the sense that we have 3 blue and 1 yellow. So we're having several conversations there. And now I have another example where we have orange and purple, right? So we've got 3 orange and 4 purple. Here we have 3 pink and 7 blue, right? So again, just a way for the students to imagine them beading these themselves. Now you've given the example, and then you give them some beads and ask them to create the ratios, so that again, we're driving home, we're driving the point home, but we're not doing it for them all the time. Now they have an opportunity to experience it. We could essentially take any household items or classroom items to do the same. I've got some straws here. So for just this one example, I've used straws. I'm using straws. I used beads, and I used the graph paper and scissors and colored pencils to make the tape diagram. So in this case, some of my straws have unicorns, some have rainbows. Yeah, unicorns and rainbows. So I might ask the students, okay, how many straws have unicorns? How many have ratios? How many have rainbows? I might ask them the ratio of green straws to, what do we have here? Pink straws. Okay, so we could do it any number of ways with these particular straws. But even if you had, just regular straws, you could bundle them together and have 2 bundles. How many is in this bundle versus how many are in the other bundle, and have that have a similar conversation. So again, you can take any number of objects that you find in the classroom. You could use pencils, just regular pencils. You could do this. Let's see, I've got regular pencils here. I've got 5 regular pencils, and then I have 4 fancy pencils or printed pencils, or I could ask sharpened pencils to unsharpened pencils, right? So again, we don't have to get fancy. We can just look around the room and gather things that are going to be manipulatives for our students, so that they can transition from the concrete to the representational to the abstract eventually. All right, so we did graph paper and scissors, beads and strings, straws, pencils. What else? Now let's talk about colored pencils. And this is, I'm going to end with colored pencils. And I'm ending with colored pencils because it surprised me how many things we can do with colored pencils. And so again, just something that's very visually stimulating for our students, but helps us to reinforce the skills that we're teaching. So if we were in we're in Unit 10, Module 7, there are many, many activity sheets in there that call for colored pencils. In this case, it's recognizing angles and shapes as a part of circles. And we're going to use colored pencils to trace angles. We're going to use colored pencils to shade in the spaces inside two rays. So now we're doing angles, we're using the rays and coloring inside the space. We're going to use different colored pencils and a ruler to, and the protractor as well, to draw a 45-degree angle. Then we're going to say, all right, now what I want you to do is use your brown colored pencil to draw an angle that is half of the 45-degree angle. So we colored the 45-degree angle. Let's say we colored it in yellow, and now we're going to use our brown colored pencil to draw or to shade in half of that 45-degree angle. Now we can have the conversation, what is half of 45? So it's going to be around 22.5 degrees, right? We can have them to use their ruler and a red colored pencil to draw perpendicular lines, right? So all of these examples are not examples that I made up. They're examples that come directly from the TouchMath curriculum, but they're not something that you necessarily have to go out and buy, or if you do, it's not a huge expense. Everything that I've shown you here today are things that you would find in the typical classroom. And if you are using TouchMath, of course, then you have access to these as well. If you have access, even if you're not already using TouchMath. But I did want to point out that in the shapes toolkit, you have those additional resources available to you. So that is my, those are my top 10 manipulatives for TouchMath.